sleep here, okay? I'm just trying tilt it here, okay, slightly less than 90 degrees, just for explanation. And then you have to describe this kind of waveform, and this waveform has very sharp edge. Sharp edge is this sharp edge here. Or you can say steep slopes, almost 90 degrees. Okay? You are describing this waveform, okay, in step 6b. And the most important thing is this square waveform is very stable against the change of triggering level. Okay? Even if the triggering level is changed from here to here, you know, the starting point does not change so much horizontally. Okay? In the case of sinusoidal wave, it's unstable because the center is like this, okay? And the triggering level is here. It starts at this point, okay? But if the triggering level is slightly shifted upward, you see how important the figure. Okay, this point. This triggering level is shifted like this. Okay, at this point. The triggering level is slightly up. Okay, it starts around here. No? So horizontally it will be shifted. This much will from here to here. Okay, this kind of thing causes instability. Waveform on the screen. Okay, remember you used triggering level control when you did the oscilloscope in the second week of the semester, I believe. So anyway, what you have to write is the stability against the wide range of triggering level control change. Wide range, okay? Wide range means here. This is almost the same point. The horizontally it does not move, okay? That's the meaning of stability. So you got it, no? There are three key phrases you have to mention, okay? Such as stable waveform, steep slopes, or sharp edges, and the wide range of triggering level. Because these three you have to mention, okay? You have to see why they are asking this kind of question also in physics. They are trying to see your understanding of triggering level. That's why. That's what they are checking. If you know their purpose of asking you a question, then you can properly answer the question. Okay? Here we are just, you are asked to describe the waveform. Okay? Description of waveform. They are not asking you why this happens. Okay? When they ask you to describe what you see, you have to give only the description. Okay? They are not asking you why this happens. Okay, so that's about step 6b. Okay. Next page, page 23. Okay, this can be also done at home, the whole page. In other words, steps 6c and 6e. Those can be done at home, but I will give you also the hints. For the step 6c, now we have to answer why this is happening. Why this happens. Here you have to give the reason, okay? Physical reason. Okay? How the answer is like this, because of this steep slope here. Steep slope of the square wave. Even if the triggering level is changed for a wide range from here to here, relatively wide range, okay? The waveform is stable. In other words, the display is not affected. Okay? Until it reaches the peak voltage like this, the peak voltage. So bottom voltage, bottom or minimal voltage, and so on. That way you have to answer, okay? They are testing if you understood the meaning of this triangle level applied to this square wave. So key phrases are like this: steep slope, square wave, triggering level, stable waveform, wide range. So that way, those things we have to use. Okay? Any question? I don't write them here because you just copy them without thinking. So anyway, this is testing you if you understood triggering level applied to this kind of special square wave. Next step is 6E. 6E, okay? Page 23. In the same page. Okay? This is about the change when you flip from positive slope control to negative slope control. Okay? So in the case of positive slope control, it should look like this one, the first one. If you use the negative slope control, it will shift like this. Okay. This is the positive slope control. Slope control positive level. This is positive, okay? You change from positive to negative. So this rising edge. Okay? This rising. This falling edge. So it's clear that the oscilloscope will start. It's a rising edge, rising slope for the positive slope control case. If you flip it to negative, it will be like this. Okay? Then you have to answer how much shift is made. How much shift? Horizontal shift. By this time, you guys know where to where is one period. Where to where? Yeah, to where? Yeah?
No.
Yes or no? This one, no? From here to here is one period, okay? Please don't say that from here to here is one period, okay? Why not? Because period is minimum segment that's repeated. From here to here is not repeated because this part is different from this part. So you have to include the whole part here. Then this part is repeated. Okay, don't include, don't double it like from here to. That's not the minimal. Minimal one is from here to here. Okay, this one is repeated. Okay, from here to here is one period. Okay, so you have to see how much shift happens when the slope control is changed from positive to negative. That's what you have to answer. Okay? The key phrases are how much shift it makes. Okay, I don't answer the question because it's your job to answer the question. Okay, I'm giving you only the hint. Okay, how much shift is made from this graph to this graph? It's clear. No? Okay, so key phrase amount of shift and positive and negative slope control. So that's step 6E. Step 7A you have to do here in this lab. Okay? I give you some good role model here, okay? There are 5 different curves you have to draw within the same graph here. Okay? 5 different graphs, 5 different curves. You see this kind of thing and this kind. This is the last one. This is the second or third one. Okay? Actually, it's, I have to avoid confusion. I have to cut this one because you have to draw only this part and yeah, this part. Anyway, you have to draw 5 different curves. These 5 different curves are for 5 different values of capacities. Okay? Those values are given in page 16 again. Page 16. 7A around here. They give you 5 different capacities. 0.000 microfarad, 0.003 microfarads, up to 0.10 microfarads. Okay? Those 5 values you have to plot, okay? Okay? It's in the same graph. Yeah. You have to superimpose 5 different cases of the capacities. Okay? And I have to tell you also small things like the v-axis, okay? This is v versus t graph. The v-axis should be the horizontal center here, okay? Division from the left, okay, here. This should be used as the v-axis. And the t-axis should be one grid line, one major grid line from the bottom line. Okay, that's t-axis. So the coordinate origin should be around here, okay? One division from the bottom and 5 divisions from the left. Here. Anyway, I'll show you again when your representative come. Anyway, that's the thing about 7A. And 7B is like this. We are asking why this becomes flatter and flatter when C increases. You can answer in 2 different ways. I mean, the one way of doing it is just cite this kind of function, where if C increases, then tau increases. If tau increases, then the coefficient for this exponent decreases. No? Decreases means this exponential function is decaying very slowly. Okay? That's why from here to here, if C increases, it becomes flatter and flatter. That way you can answer, okay? Another way of answering the question is to use the Markov's. Because the current value itself is the same. And there's a relationship between the current charge. And if, you know, on the other hand, the charge and the capacity related to delta V like this. So you can use this relationship so that if C increases, then delta V decreases. Things like this. Okay. Anyway, the thing you have to use here is the fact that delta Q is the same even if C changes. Okay. Anyway, that's step 7B. Okay. Last step is A to C. I'm talking about page 25. By the way. A to C. They are asking why tau value is the same for 2 different sets of values for R and C. Okay. You have to give this key equation. Okay. If you don't give, then you get deducted. Okay. Without this relationship, you cannot answer correctly or properly. Okay. You cite this, then substitute numerical numbers, then compare tau value. Tau is called time constant. Any questions among us? And I give you also some additional auxiliary. I mean, for page 25, okay, step 7A, for drawing this kind of graph, of course you have to put the symbols, units, and the coordinate numbers here, okay? Don't forget to record the scale of your screen, your display. That's very important in physics, okay? What kind of scale you choose. Millisecond or microsecond, okay? Those are completely different. Okay? So the hint is that the vertically it's 1 volt per division. The horizontally it's 0.2 milliseconds per division. Okay. Any question at this moment? If no, then I have to call your representative to come here to